In APCSP, the topics of privacy and security usually touch on things like cyber attacks for security, and they touch on things like data privacy and various other forms of privacy. They also touch on encryption, which we will actually cover in a separate video. Now we'll start here with this classic question. I've seen this question a lot. I've seen it in exams. I've seen it in practice exams. It's a really big question, and this one I really like to use as an example. So actually, the first thing we notice is that what they're asking about here is which of these things compromises a user's personal privacy. So we're looking about privacy here, not security. Now, privacy means that your private information is released to others. It's stuff that you wouldn't want others to know about you. We can start right away by eliminating these two, B and D. These are both public pieces of information. Public key is about encryption. We'll talk about that in another video, but it is public information. This is not private. Same with IP address. IP address is also public information about you. We learned about that in the internet section. Now, most people, when I give this in a quiz or a test, they will jump right to C because they say, well, I wouldn't want to share my email address so people could email me spam. The fact of the matter is, as much as it kind of stinks to have other people email you spam, just knowing your email address on its own is not enough to really compromise your privacy. When we talk about privacy, generally one piece of data is not enough to really say much about you unless it's paired with other information, such as maybe your name, personal interests, what kind of things you shopped for, what kind of things you like or don't like. And by the way, this also means that things like your house address are not really on their own private information. You can find anyone's house address on Google Maps or just stepping outside your house and just looking outside at a mailbox. You can see somebody's house address. Unless you know more information about them, it doesn't really do anything to hamper their privacy because you can't really associate that house address with anything private about that person. You can think of it as even a credit card number on its own is not that private unless it's paired with the information for how to use it, such as the billing zip code and stuff like that. And the reason for that is because you could generate just any credit card number. You could just randomly generate numbers and that can be a credit card number, but you don't know enough information to actually be able to use it. So the big takeaway here is for things like C, just the single piece of information is not enough to really do much about personal privacy. Now, when we talk about cookies here, cookies actually store a large amount of personal information, and when those are all combined, you can actually learn a lot about a person, right? So your web browser has a bunch of this information tracked. Some of it is useful, like it might help you log back into a website without having to put your password back in, which is pretty handy. But some of that information might be stuff that you wouldn't want others to read. So the answer to this one is A. Now this question here is about anonymous browsing sessions. You might know this more commonly, at least if you use Chrome, as incognito mode. Believe it or not, this actually is just a question about cookies. And specifically, even if you're not sure how anonymous Windows or incognito mode is related to cookies, they tell you right here. It says, when the anonymous window is exited, cookies created during the session are deleted. That's really all you have to know about what incognito mode or anonymous browsing is. So basically the different things that you're seeing in the answers here are which of these are true about deleting cookies. Now, cookies store information on your browser, basically on your computer. However, it's important to know that it doesn't affect your network interactions. It doesn't affect information you send over the wire. So just as without incognito mode, that type of activity is still visible to others. Now, even though cookies do store information about your login session for when you want to come back later, it does mention that these cookies are deleted at the end of the session when you close the window. So until then, you can still actually log in to email and things like that. And importantly, just deleting cookies doesn't mean that you are not susceptible to viruses or to things like downloading harmful executable files and things like that. So these are all out, which means the answer is B, but let's look a little closer at this. The only thing on the APCSP curriculum that it actually says concretely about cookies is the following statement, which I'll show here, which is that disparate personal data such as geolocation, cookies, and browsing history can be aggregated to create knowledge about an individual. This is what we talked about in the previous problem, but the notable thing here is that it doesn't really say much about what type of information cookies are actually tracking. Now, one example of the kind of thing that cookies are usually shown to track are things like your shopping cart. Like if you're on Amazon or something and you're buying something, it'll add it to a shopping cart. If you're browsing anonymously, if this information is stored in a cookie, it's going to be deleted after you stop browsing. But this is actually a little bit outdated because a lot of websites don't store this stuff in cookies anymore. They actually store it in a server. So this is a question which I will very reluctantly say B is the answer here because that's what was intended. They're suggesting that this is the kind of information that would be stored locally by your computer when you're using cookies. Now the one saving grace here is that although that is kind of just used as an example, it does say here specifically in the anonymous browsing session, it will not be saved on the user's computer. So it could be saying that in case they do use shopping cart for that kind of information. It's not going to be saved in your computer, which does make B a little closer to the truth, but still reluctantly so. Now here's an absolute beast of a problem that has a whole bunch of stuff, but the good news actually is you don't actually need to read any of this text up here in order to see what the answer actually is. You only actually need to focus on this little part of the prompt here, which is, which of the following is most likely to be a data privacy concern for this app here, which they call Run Router. So just from that information, you can look at each of the answers and see that 3 of them do not describe data privacy concerns at all. A mentions that the users are required to carry their smartphones in order to use this. That's not a data privacy concern at all. That's just an inconvenience. That doesn't even come close to describing data privacy concerns. C mentions that they may not be able to accurately track their running history. Once again, that's just kind of a usability issue. It doesn't really mean anything in terms of data privacy concerns. And D is also not about privacy at all. It just says that your application might not be compatible with other users in the area. Really, the only one that talks about data privacy at all is B here. B is describing a scenario where the user of the application may be able to determine information about the locations of other users that are not in their contact list. That's actually described up here, by the way. Users' routes are shared with other compatible users in the area so they can run together. It also specifically mentions that they're compatible if they are in each other's contact list or just if they typically run at the similar speeds. But you don't really need to know about any of this stuff here. It doesn't matter because this is the only thing that comes even close to describing a data privacy concern. Data privacy concerns are really just when your information is made available to people you don't want to have your personal information. Okay, that's enough about data privacy. Let's cover some stuff about security and cybersecurity. This question here is about multi-factor authentication. So multi-factor authentication is defined where access to something is guarded by at least 2 of these 3. You need something that has to do with knowledge, so something you know, something you have, so something you possess, or something you are, so they call this inheritance. So something that is knowledge is considered something like a password or a PIN number, something just kind of remember. Something you have is a thing you can possess, like a phone or an email address. And inheritance is kind of tricky. So for example, biometric data, such as your thumbprints or your facial recognition. Of all of these, the only one that clearly shows 2 different factors is C, which shows that you have to enter a password, which is something you know, and you also need to enter a code, which is sent to your phone via text message, and the phone is something you have. All right, here we go. Here's a question about phishing. So this is our first cyber crime that we're talking about here. So phishing is when somebody uses some kind of psychological attack, which means basically that they're trying to trick you into giving away information. Phishing, I believe, is the most common type of cybercrime. It's very common. If you have an email or even a cell phone, you've probably been the target of this type of cybercrime already. Like somebody's already probably tried to send you a phishing email or text message. So in this question it says the customer suspects that this email might be a phishing attempt. Which of the following is most likely to be a privacy risk, or I would say security risk to the bank customer? So basically it says which of these 4 is the wrong thing to do. The other 3 are correct things to do. One of them is wrong. So calling the bank at its official phone number is probably one of the best ways to handle this. Make sure that it's legitimate. Checking the domain name of the email will see if it is legitimately from the bank. So if you get something from Chase, check that the domain from the email, such as chase.com, is legitimate. It's not coming from some other weird domain. D is kind of more generic, just says kind of look online to see if others have seen the same email. It's, it's whatever. So A, C, and D are all things that are okay to do. There's no risk in doing these things. Now, obviously, if it is a phishing attempt, calling the phone number is just a bad idea, especially if you provide the personal information over the phone. So this is pretty clearly the one that is a privacy risk here. This question is about keylogger. So keylogging is when you have some software that's installed in your computer known as malware. Malware is software that's kind of malicious that is installed in your computer, which one form is a virus, and another form, among many others, is keylogger. So keylogger is a specific type of malware, and what a keylogger does is it will be installed in your computer and it will record all of your user input, so everything you type in your keyboard, and it will then send it to another computer. And then what it does is give whoever installed that the ability to look at what you've been typing. Among other things, this will let them see the passwords that you've been typing and what you've been using those passwords for, and that would allow them to access your computer remotely, right? So this is basically just recording your activity in your keyboard so that they can basically type in your password and access your information. Lastly, the last cyber attack we'll talk about here is rogue access exploit. A rogue access exploit is basically defined exactly by what A says right here. A is the answer here. It says an unauthorized individual gains the ability to view network traffic by connecting to a network router that uses weak to no security measures. So basically an unsecured router, a router without password, stuff like that. Somebody connects to it and then they can see everything that gets sent through it, at least information that's not encrypted. Just real quick here, C is talking about attempts to trick a user. As we know, that's describing phishing. And D is describing a cyber attack we didn't talk about yet, which is a DDoS attack, distributed denial of service attack. This question here is about passwords. It's actually a great question here because a lot of people from watching movies come to assume that the way that hacking works, the way that passwords are cracked, is that there's some kind of magic that a hacker performs and they somehow uncover a password. But that's actually not the truth. The way that passwords usually are uncovered is from a combination of psychological techniques to have them somehow reveal their password or give it away, or the use of data mining, which is, for example, you might have a database of common passwords. So if your password is ABC123, you can check an online database to find that that's one of the most common passwords. So what a hacker might do is they might just try maybe the top 1 million most common passwords. If your password is really weak and appears in one of those databases, that's going to be very easy to guess your password just by trying those. Which means that the answer is D here. If you use a weak password, as is suggested up here, it's just something that's much more likely for somebody else to guess using some kind of data mining techniques, such as just looking it up in online databases.